So here we're going to look at projectiles and vertical projectiles, so straight up and down. In this question, we're told that a small ball is projected with a speed of 17 meters per second upwards from a point which is 50 meters above the ground. Now, there's lots of different things that we can be asked about this journey, and I split this into 4 different sections. We'll start with the journey to the ground, so from the point of projection until the point where it hits the ground. So that's only 2 pieces of information, but they're both important, and there's lots that we can do with these. The very first thing I'm going to do is I'm going to sketch a diagram, and you should do this for every question. The distance above the ground, I've just drawn a little platform, is 50 meters. And the positive direction, the direction you are initially moving in, is upwards. This is very important to pick the values we're going to work with through this question. Now, there's lots of different scenarios we can talk about, and I've split this into 4 different sections. We're going to start with the journey from the point of projection to the ground. 2 things we can find here. We should be able to find the time that takes, and we should be able to find the velocity with which we hit the ground. Okay, let's start by collecting some SUVAT variables. What do we know about the journey that starts at the top of the platform and ends on the ground? So, firstly, the displacement is going to be negative 50. It's in the opposite direction to our positive. It's in the opposite direction to the initial movement. Displacement is negative 50. The initial velocity, we're told in the question. V, we do not know. Acceleration here is due to gravity, so it's negative 9.8. Okay, these 2 unknowns are the things we're attempting to find. So, if we're looking for time, we'll choose a SUVAT equation that uses SU, A, and T. So, S equals UT plus half AT squared, and we'll substitute our values in. Negative 50, 17t, and negative 4.9 t squared. Okay, this is a quadratic equation to be solved. We can rearrange and we can solve this any of the ways that you know how to solve, either the quadratic formula, if you could factorize and solve, if you could complete the square to solve, or if you simply use the equation solver on your calculator. We're going to get 2 times. So we have 1, which is actually negative 1.9, which isn't going to be so useful to us, and the other one is 5.37. We have to show that we're not going to use negative 1.9. This means if we went back in time 1.9 seconds, the ball would have been on the ground. Okay, not useful in our context. So the time for the ball to get to the ground, 5.37 seconds. How about velocity? Okay, so we're going to use S, U, V, and A. The formula is V squared equals U squared plus 2AS. And we're going to go ahead and substitute our values once again. So, unknown velocity, that's what we're looking for. And we've got 17 squared, subtract 19.6, multiplied by negative 50. Okay, don't really need a calculator until this step here. And into the calculator, we get a velocity of 35.6. Now, we did square root, and that would have given us either a positive or negative velocity. And since we're heading towards the ground, this velocity should actually be negative 35.6. The speed is 35.6, but what direction are we moving? Downwards, which means we should have negative velocity. Another journey that we're often asked to work with is the journey from the point of projection to where it has its greatest height. Now, it has its greatest height when it's about to change direction. The particle has been moving with positive velocity. Before it starts to move with negative velocity, it's going to have 0 velocity. We know at the greatest height, the vertical velocity will be 0. So there are some things we can find here. Displacement, height above the ground, and the time it takes to get there. So let's start with displacement. The SUVAT variables we know and we can work with. We have unknown displacement. The initial velocity is 17, final velocity of 0, acceleration is due to gravity, and we have an unknown time. So the displacement we can find by using V squared equals U squared plus 2AS. We'll substitute in the values that we're aware of, and we'll rearrange. S is going to equal 17 squared over 19.6. into our calculator and we get 14.74. So that's the displacement from the point of projection to the greatest height. The question may have actually been about the height above the ground. Well, since we were initially 50 meters above the ground and we've now had a displacement of 14.74, altogether our height above the ground is 64.74. We'll just simply add those two together. So just be on the lookout for which of these two the question is asking for. The time it takes to get to that greatest height. We'll use v equals u plus at, put our values in, and that time is going to be 17 divided by 9.8. So that's a time of 1.73 seconds. So these are the things we can be asked about a journey to the greatest height. A less popular but very important type of question is when we're asked to find for how long was the particle above a certain height. So in this question, I've decided to find for how long was the ball more than 52 meters above the ground. Well, the ball started 50 meters above the ground, so we only really need to think about a displacement of 2. A displacement of 2 will take us to 52 meters above the ground. So for how long was the ball's displacement above 2? To do this, we're going to find the times when the displacement was exactly 2. We'll collect our SUAT variables: displacement of 2, initial of 17, unknown velocity, acceleration due to gravity, and unknown time. Let's find the times that fit this situation. So the formula to use, S equals ut plus half at squared. Substituting in our values, we're going to give ourselves a quadratic that we want to go ahead and solve. So solving for this quadratic, we get a quadratic which we want to go ahead and solve. We can rearrange. I'll take a positive 4.9t squared, negative 17t, plus 2 equals 0. And that gives us two values for t. The first time it has a displacement of 2, t1, 0.12 seconds. The second time it has a displacement of 2, when it's on its way back down towards the ground, the second time it has a displacement of 2 would be when time equals 3.35. In between those two times, its displacement was greater than 2. It was above 2. It was above a displacement of 2. It was above 52 meters from the ground. The difference between those two times is how long it was above there. 3.23 seconds. Okay, we may want to know what is the velocity when it reached that point. The velocity we can find using v squared equals u squared plus 2as. We'll substitute in the values that we have. This is a nice one. We're just going to square root the right hand side. This can all go into our calculator and we get an answer where the velocity is 15.8. Now, that velocity was square rooted, so really there's a positive and a negative result. It would have a velocity of positive 15.8 on the way up and a velocity of negative 15.8 on the way down. We're still talking about the exact point of being 52 meters above the ground, of having a displacement of 2 from its starting point. And finally, we might want to talk about the total distance traveled. We know it travels 14.74 meters to its greatest height. There'll be another 14.74 meters for it to get back to its projection level, and then 50 meters to take it down to the ground. There is no SUAT formula that will work this out for you directly. This will come from sensible use of a diagram and just tracking the journey on the way up and then back on the way down. So we get our displacement of 14.74 on the way up, 14.74 and 50 on the way down. Adding all of this together, 79.48 is the total distance traveled. So here we've gone for almost full coverage of projectile questions. Either the journey is from the point of projection to the ground, from the point of projection to the greatest height, or from the point of projection to a specific value, a specific height above the ground, or talking about the whole journey. Every single time, a sensible diagram will set you off. You collect the SUVAT variables that are relevant, and then you choose the appropriate SUVAT constant acceleration formula to substitute into and solve.